Space, the final frontier. It has beckoned humanity for centuries, sparking our imaginations and driving our technological advancements. Yet as we venture further into the cosmos, we leave behind a growing problem: space debris. This debris, remnants of our space exploration endeavors, poses a serious threat to the very future of space travel. We call this danger the Kessler Syndrome. Imagine a massive cascading chain reaction in low Earth orbit. A scenario where collisions between satellites and debris create more debris, leading to even more collisions. This is the essence of the Kessler Syndrome. It's a self-sustaining cascade of collisions that could ultimately create an impenetrable barrier around our planet. Understanding the Kessler Syndrome is not just the concern of scientists and engineers. As we push the boundaries of space exploration, we must also acknowledge and address the growing problem of space debris. Our exploration of space began in 1957 with the launch of Sputnik 1, Earth's first artificial satellite. This momentous event marked the dawn of the space age. However, it also marked the beginning of our space debris problem. With each passing mission, we left behind rocket parts, defunct satellites, and fragments from explosions and collisions, all contributing to a growing cloud of debris orbiting our planet. In the 1970s, NASA scientist Donald J. Kessler began studying the long-term effects of space debris. He recognized the potential for a runaway chain reaction of collisions in low Earth orbit. This phenomenon, later dubbed the Kessler Syndrome, painted a stark picture of the potential consequences of our actions in space. Initially, the idea of a debris-choked space environment seemed like a distant threat. However, as the years passed and our spacefaring activities intensified, the reality of the Kessler Syndrome became increasingly clear. Today, the Kessler Syndrome is not merely a theoretical concept, but a very real and pressing concern. The most alarming aspect of the Kessler Syndrome is its potential to create a runaway chain reaction. Each collision in space generates thousands of new pieces of debris, each capable of causing further collisions. This self-sustaining cascade could quickly spiral out of control, transforming low Earth orbit into a minefield of high-speed projectiles. Scientists talk about a tipping point or critical density in relation to the Kessler Syndrome. This refers to a point of no return, where the density of debris in orbit becomes so high that collisions are inevitable and the cascade becomes self-sustaining. Once this threshold is crossed, it would be incredibly difficult, if not impossible, to reverse the process. The very orbits we rely on for communication, navigation, and Earth observation would become too dangerous to use. Satellites, both commercial and scientific, would be at constant risk of destruction. The increasing number of satellites and debris in orbit brings us closer to that critical density with each passing day. It's a sobering reminder that our actions in space have consequences and we must act now to prevent an irreversible disaster. Section 4. Contributing to the mess factors increasing space debris. While the Kessler Syndrome is a complex issue, several key factors contribute to the increasing amount of space debris. Understanding these factors is crucial in developing effective mitigation strategies and ensuring the long-term sustainability of our space activities. One significant contributor is the sheer number of objects we've launched into space. Since the dawn of the space age, we've sent thousands of satellites, rockets, and probes into orbit. Many of these objects have long since ceased operation, becoming derelict spacecraft drifting through space, posing a collision risk. Another factor is the intentional destruction of satellites. Anti-satellite tests, while intended to demonstrate military capabilities, create vast amounts of debris that can linger in orbit for decades, if not centuries. Furthermore, accidental explosions in space also contribute to the debris field. Addressing the problem of space debris requires a multifaceted approach that includes reducing the number of objects launched into space, implementing debris mitigation measures on existing and future spacecraft, and developing technologies for active debris removal. Section 5. Space Junk Solutions. How to mitigate the Kessler Syndrome. Faced with the growing threat of the Kessler Syndrome, the global space community is actively researching and implementing various mitigation solutions. These efforts aim to reduce the creation of new debris, track and monitor existing debris, and even remove debris from orbit. One promising approach is to design spacecraft with end-of-life disposal plans. This includes deorbiting satellites after their operational life, either by steering them into the Earth's atmosphere to burn up, or by moving them to graveyard orbits far from active satellites. Another strategy involves developing technologies for active debris removal. Concepts like laser brooms, which use powerful lasers to nudge debris into safer orbits or deorbit them, are being explored. Other ideas involve robotic missions designed to capture and remove large pieces of debris from orbit. International cooperation is also crucial in tackling the space debris issue. Through technological innovation, international cooperation, and responsible space practices, we can mitigate the risks posed by space debris and ensure that the final frontier remains open for exploration and discovery for generations to come.